Here we have a skateboard. It's completely at rest. This demonstrates Newton's first law that an object at rest will stay at rest, and if it is pushed, the object will stay in motion at a constant speed forever until an outside force acts upon it, like the friction of the road on the wheels and the curb. He is using this size skateboard because it is not too big or too small. A longboard, for instance, would be too big to do tricks on. The more mass of the object, the more difficult to start moving and stop moving the object. The same thing also applies to the person standing on the board. We can see the deflection of the two different masses on the board. Hunter's mass is larger than Tristan, so it would be harder for him to do tricks. So how fast will Tristan himself be moving? The relative motion depends on Tristan's speed, the skateboard speed, and the reference frame being measured. Relative to the skateboard, he is not moving, where relative to the ground, he's moving as fast as the skateboard. If he jumps off relative to the skateboard, he will be moving slower than he would be relative to the ground. What makes Tristan be able to stay on the board? The skateboard he's on forces up against gravity shown by the free body diagram. We can see all the forces acting upon Tristan as he skates. This phenomenon can be explained by Newton's third law. For every force applied to an object by another object, there is an equal and opposite force applied by the first object. Another example of this would be Tristan doing a tray flip. The downward force of the board against the ground produces an upward force of the ground against the board. Another important factor of skating is the shoes of the skater. Skating shoes are designed to make sure the skater is sure-footed on the board. The grip on the sole of the shoe and the grip tape on the board creates enough friction for the skater to stay in the board and manipulate it.
As I push the skateboard, I'm doing work. Work is accomplished when a force is applied on an object over a distance. Right then, I had positive acceleration as I gained speed from rest. The game is called Skate. It's like horse but for skaters. One skater sets a trick for the other skater to copy. First trick is an ollie off the stairs. Here, I have both horizontal and vertical motion of a projectile as I jump off the stairs. If I had a lot of speed when jumping the stairs, I would still land at the same time as if I did. Now, I will be launching off a ramp. The curved path I create is called a parabola. The angle at which I jump determines my range and how high I will go. The greatest range can be achieved if I launch out of the ramp at a 45-degree angle. If I left the ramp at a 70-degree angle, I would go high, but only as far as if I left the ramp at a 20-degree angle.